Hello, I am Masfin, and I am here today to analyze the KwaZulu-Natal flood that occurred in 2022. I'm interested to analyze it. So before I'm going to show my analysis in ArcGIS, let us see together the catchment I studied in this map. One of the catchment I studied is the Umugani catchment. You can see the river, Umugani River. See the people where they are living just by the side of the river. This is a big river. It's not a joke. It's not a joke. I think this bridge already, I think, damaged or maybe broken by the flood. I don't know. But that is it. This is Umagani, and this area is it seems for me, vulnerable to the river, to the flooding. But we will analyze it using the ArcGIS with real data. And the analysis is just, the result is just perfect. I mean, it indicates that the flood zone, the groundwater potential zones, and so on. Actually, Umagani is protected by the dam on the upstream side. The reservoir might temporarily hold the water as long as the water can be contained in the dam. You can see this gorge. People are living still here. Poof. Oh, people are living here. If the flood comes here, or people must not live here, it should be protected by the law. The government has to, move these people to other places. Otherwise, if flooding comes, dangerous. I don't know how people they are living here. That is Inanda Dam. Yeah, it is Inanda Dam. It's a rockfill maybe, or earthfill, I don't know. But the spillway is concrete. It seems a very big dam. And along the way there is also a very small dam, I think. But it's not visible here. This is the Albert Fall Dam. And the Albert Fall Dam is connected with the Midimar Dam, That is Midimar in Hawik. This is Peter Masberg. It is flat land, actually. Although it is the elevation is 2,000 meters, it seems it's flat around this area. This is just an elevated land here. I used to see this mountainous area, very small mountain actually, cliff maybe. I used to see it from my room. Yes, people used to jump here by the paraglider, I think, so in France, paraglider. So this is it. The study I conducted is in this catchment, Umagani catchment. What I did is I studied the catchment flood risk zone and also the groundwater potential zone. And also I studied in the KwaZulu-Natal, the groundwater fluctuation. See, there are places in KwaZulu-Natal where the borers, the well, or groundwater well, located in they record them always and study them. So as long as there is recorded data, seasonally, the groundwater fluctuates. So it's possible to analyze and calculate the fluctuation of the depth of the water table, the depth of the groundwater. That is it. So I did that. We can see the flooding. The flooding that happened in KwaZulu-Natal, maybe, just simply to see the flooding. It was devastating. It needs further study. People have to study. They have to give attention to hydrology, and they have to find a solution for this, I think. So the government has to allocate budgets to hydrology. Yes, the hydrology department has to study this flooding. Yes, that is very dangerous. We can see also the other one. You can see this. That is it. This is the flood that occurred in 2022 in KwaZulu-Natal, Durban, Newcastle, Mpumalanga, all of the places, So, let me show you what I did. Okay. Before showing you the results, let me explain my data. I think so. First of all, we need to have data of digital elevation model. From the digital elevation model, we can calculate the slope, we can calculate the drainage density, we can do the elevation thing, So before we analyze the digital elevation model for hydrological analysis, there are processes. You have to fill the sink, the hydrologic processing the digital elevation model for hydrologic analysis. You see, there is a hydrology, where is spatial analysis? Yes, hydrology, you see. We have to fill it, estimate the flow accumulation, or calculate the flow accumulation, flow direction, and so on. The data I used is the digital elevation model. And this is, you can see the density all extracted from this digital elevation model. That is, and the rainfall that I got in a net CDF format, that is available on the internet as well. This is the rainfall in raster format, gridded rainfall. We need that. That is for the whole world. Yeah, that is for the whole world. We can do that. You can see it. That is for the whole world. And soil map. That is a soil map. of the whole world, we have to extract for the catchment we are going to study. This is a land cover. Land cover. That's the land cover, you see. That is the land cover of we can do it. That is. Let us do this. You see, that is the catchment I studied. This is the land cover. This is the Durban area. That is the Inanda Dam. There is a small dam around. This is the Albert Falls, and this is Middenmar. This is Peter Masberg. That's Howick. And this is Pinetown. Pumulanga is around this area. This is agricultural land. Pumulanga is an agricultural land. So these are the data I use. So land cover, soil map, rainfall, annual rainfall. I have to extract this into usable format, and these are the data I used. So let me show you the result I obtained from my analysis. First, let us see the Durban one. Let us stop this one and see the Durban analysis. Before arriving into, the data has to be formatted, steps into different type of files, and finally we arrive into a classified format. We have to classify. This is a classified format of the final data prepared by me. After that, we start analyzing, overlaying those data into. That is the principle of, the way that we study the flood risk or groundwater potential is by overlaying all of this data. For example, density, rainfall, slope, digital elevation model for elevation and so on, soil map, land use, land cover map. We just overlay them and determine the percent of influence of each of these layers, and then we give a scale factor which place has to have a higher scale and so on. Then we analyze, and the result I obtained is this. This is the result for flood risk zone. We can see the flood risk zone of KwaZulu-Natal is this. Number 5 indicates that highly risky area is this one, around Durban area. And then the other, for Peter Masberg, also Pinetown, also this agricultural land. Around Pumulanga is small, very small. But that is out of the catchment area. The areas around this elevated area, higher elevation, low flood risk zone, we can say. But this means, it doesn't mean that whenever it rains, the Durban area is going to be flooded. And it's not like that. It's contextual. It is relative to the other places in the same catchment. It means in Durban area is more vulnerable than the Pietermaritzburg. It doesn't tell anything. The rainfall, annual rainfall of Durban is around 1,000. It's not much. And Pietermaritzburg is around 800 or something like that. We can see the rainfall pattern before the college classification. Durban is, you see, the Durban area, so we can see that the rainfall of Durban. You see, that is it. Durban rainfall. That is Durban rainfall. In the 918 up to 1000, this is the area where annual rainfall is not much. The rainfall is not much. And whenever it rains, it doesn't mean that the area will be flooded. It means the flooding occurs when there is an event, high intensity rainfall. The annual rainfall is a rainfall that spreads throughout the day. It is the sum of the whole year rainfall. But the flooding comes when high intensity rainfall pour to the area. If that extreme event falls, higher intensity rainfall falls, relatively from all this area in this catchment, the Durban area is a highly risky flood zone. It might be flooded by the rain that falls if it is extreme, if it is greater than the infiltration capacity of the soil. So while analyzing, you see, the ArcGIS considers all of this, the soil type, you see, if it is clay, runoff is high, and so on. So the soil type affects, and the land cover also affects if it is asphalted or something like that, compacted soil. So infiltration might have difficulty, you know. If there is any difficulty to infiltrate the water easily, then, you know, it will be a runoff. So all those criteria are included in the analysis. For example, in a mountainous area where it's impossible, you know, that area to be flooded by, because the water, it's a steep slope, it goes down, even if it rains, and, you know, always water retaining. I mean, the water, it can't stay up, it will go down. Water find its level always. It go down and spread to the lowland areas and stay in a level surface, groundwater table. Everything needs to be in equilibrium. That is physics. So these are this is the idea, and also these are the data we use to analyze. This is one of them. The rainfall here, for example, around this mountainous area is low. It's not mountainous actually. It's 2000. The division is Pietermaritzburg and surrounding area. The rainfall in Pietermaritzburg, there is not much difference between Pietermaritzburg and Durban area. There is 90 kilometers far from, so the rainfall is almost similar. So although it's not that the rainfall that's causing the flooding. It is an extreme event. It is a fall of a rain that when the intensity of the rain is very high. So the area at the downstream side of the catchment of Umagani catchment is affected. Is the red one, this one, very deep red. This is an area where a lot of damage will come if that rain falls. And the other areas, it's okay. This is an agricultural area. Maybe this one we can say, this area, the green area, no flooding there. That is not risky as compared to this one. You see, it must be clear that this doesn't indicate that the flooding will come always or whenever it rains. It doesn't mean that. This is just a relative thing. In that catchment, the ArcGIS analyzed it and determined those areas are vulnerable if that rain comes, that high intensity rain comes. And it may happen anytime in the year. So that is it. That is the Umagani catchment. I have also studied Tugala catchment, the same thing. I did the same for Tugala also. So this is Tugala. That is it. This is Tugala catchment, and this is the flood analysis. The risky zone is located at the Mandini and around this area. That's the downstream side of the Tugala. Tugala is a very big catchment with a dense drainage density, and it is very big catchment. So this is the area where the rangeland occurs. The greens are mountainous, you see. In the mountain, no flooding. In the Dronkersburg area, also no flooding. But you see, Ladysmith, flooding may occur. This is true. And Newcastle, you can see the flooding. There is a possibility. Relatively, flooding can occur in Newcastle, Ladysmith, Greytown, Tugala Ferry, also vulnerable, but not as the downstream, the far end of the downstream. Madini is very, very vulnerable for flooding if that rain comes. It doesn't mean that always. If that rain comes, that may create flooding, higher intensity, extreme event it means. If it comes, the Mandini and the other areas will be damaged. So what is the remedy, the prevention? The prevention method is most of the time while people, urban planners plan, they have to consider these high flood risk zones should be avoided. Or there should be some kind of mechanism, for example, constructing a dam, a reservoir that hold the flood temporarily and release it slowly without damaging the downstream side of the downstream side residences, people, the housing, anything that is exists at the downstream side of the. So that is Tugala flooding, and the same I also analyzed the Tugala groundwater potential zone. Similar, That is the groundwater potential zone of Tugela. See, the green is the same thing. It's just the groundwater potential and the flood risk zones are almost similar. They're similar. You can't find in the mountain, in the, you can't find the ground. It's rare, I mean. It doesn't mean that you can't find, but relatively from this as compared to this area, it's very difficult here because it is a mountainous area, or you have to dig very deep, because the water goes to the lowland areas. So in Newcastle, it's a flatland area. In Ladysmith, you see here Moy River, around along Moy River. And also the same thing, the downstream Madini area, the groundwater potential is high there. So these are the analysis I did. I also studied the drought condition. What will be the drought condition in Tukala zone? This is a drought condition. Which one is vulnerable for droughts as compared to, or relatively in the catchment area, it means. So these areas, the red one, or I think the brown, it is that a brown or something lighter red? As lighter red, the lighter green, this is not affected much as compared to this area, drought. This area is drought-free area. It's always relative to the catchment, which area would be affected most if drought comes, if there is no rain, and so on. Because this one, the groundwater table is, available easily. And if there is any rain that comes down to this side, even the groundwater table also, comes to the downstream side. And so, no drought in this area. That is it. This is the analysis. I also did the same to the urban area. This is Durban area. This is outskirts of Durban. This is Durban area. This is Durban area drought analysis. Durban area drought analysis. This one is a Durban area drought analysis. You see, Pietermaritzburg is vulnerable for drought than Durban. That is it. So that is as the analysis I did. I have also did another analysis, actually, just simply to show you in Durban area, that is, you see, this is a zone, groundwater potential zone. There is also this catchment. Ndiweni, Mukohom Ndiweni, something like that. This is Zulu name. So, we can see also the soil type. So it's the soil type of the area, for example. Let us see. This is the soil type, actually. This is the soil type where we can see the soil type. The name of the soil type is okay. This is the soil type actually. We can see the level as well, value instead of soil type. That gives the soil, that is it. We can see the green is clay. There's a person, clay loam is this one. Sandy loam is, this one is sandy loam. This one is loam soil. Loam soil is just around Pumulanga and Albert Ford, around Albert Ford. Peter Masberg is clay. And Pinetown is also clay. Clay loam is this one. We are around the Kote, by the side of Pinetown maybe. So this area is loam soil. Agricultural land might be located here, Pumulanga, you see. Same thing in Tukala catchment also. The Tugela soil type, soil map you can see here. It's Tugela soil map. Tugela birds, Tugela. This is soil map of Tugela. The drought zone, covered by the drought zone. You see? That is it. Tugela soil map is here. Okay, let us see. Let us change your name, the value of the soil type. We can say the type of the soil type, the type of the soil. For example, this is clay. This red is sandy, clay loam. So, I think is, for example, the yellow is loam, clay loam. Same thing happens here as well, I think. They are connected. This one is also loam. This one is also loam. This one, the green one, is also loam soil. That is simply to show the soil type. So that's how I analyze the floods in the urban area. Okay, like this. So this is an indicator. Administrators, ArcGIS is wonderful. It's simply easy to report and display the result to the administrators, decision makers, to urban planners, so they take the area. They come up with a protection mechanism to the area where that is vulnerable to flooding. That is, the other one is I want to show the groundwater analysis I did. For example, this is the province of KwaZulu-Natal. I selected some of the groundwater wells located in the area. There is one here, one. And analyzed them and calculated the fluctuation. This is the fluctuation. For example, the red area indicates negative. Positive means again. Yes, it's positive is again. There is the higher number indicates the fluctuation is very high. This area is, the fluctuation is less, but there is a loss. But this one is, the fluctuation is high, but there is a gain. So that's how we estimate the groundwater fluctuation of the area. That's it in KwaZulu-Natal. I've got the information from the groundwater logo of KwaZulu-Natal, but I just simply add up some data to come up with, to analyze using ArcGIS. So that is it. This is the result. So it's wonderful. So that is what I studied in KwaZulu-Natal. Especially the flooding is very interesting. So I just wanted to, be used by everyone in minimize the damage of flooding is the purpose here. So that is it. Thank you very much for listening. I am happy that you listened to me. If you listened to me until this end, thank you very much.